Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So an irrigation channel is constructed by bending a sheet of metal that is 3 meter wide as shown in the diagram. What angle theta will maximize the cross-sectional area and thus the capacity of the channel? So the cross-section area here is in the form of a trapezoid, and it's an isosceles trapezoid because the two non-parallel sides are equal in length. So in this case, the side that represents the top of the trapezoid and the bottom of the trapezoid are parallel to each other. So the first thing we should do is to write the formula for area of this trapezoid because we have to find the angle theta that will maximize the cross-sectional area. So the formula for area of a trapezoid is, so it's the sum of the parallel sides times the height of the trapezoid divided by 2. Now we can label the corners of this trapezoid. So this broken line represents the top of the trapezoid. So these two broken lines here, they represent the height of this trapezoid. So the parallel sides are AD and FE. And FE is equal to 1 meter. So the distance from B to C is also equal to 1 meter. Now angle A is also equal to theta because of the Z pattern that we see here. So the alternate interior angles being formed are congruent or equal to each other. Similarly, angle D is also equal to theta because of this Z pattern that we see. Now we have to analyze triangle ABF to find the height and a side AB in terms of theta because we have to find the angle theta that will maximize the area of this trapezoid. So in this triangle, side AF is equal to 1 meter, angle A is theta, and this is the height of the trapezoid. And this is a right angle triangle. So we can use SOHCAHTOA to find the height and side AB in terms of theta. So for H, we can use sine ratio. So the formula for sine is opposite over hypotenuse. So for angle theta, the opposite side is H and the hypotenuse is 1 meter long. So H divided by 1 is just H. So this is the height of this trapezoid in terms of theta. Now we can use the cos ratio to find side AB in terms of theta. So AB over 1 is just AB. Now, since this is an isosceles trapezoid, side CD will be equal to AB. So now we can find the length of the parallel sides. So the parallel sides are FE. So we know that FE equals 1 meter, and then the other parallel side AD will be equal to the distance from A to B, which is cos theta, plus the distance from B to C, which is 1 meter, plus the distance from C to D, which is also equal to cos theta, because AB is equal to CD, because the two triangles being formed at the ends are congruent or have the same side lengths. So now we can combine like terms here. So cos theta plus cos theta is equal to 2 cos theta. So these are the expressions we can input in this area formula for the trapezoid. So we'll start with side FE because we have to write the expressions for the sum of parallel sides. So 1, now we can write the expression for AD. And the height, and we found that height is equal to sine theta over 2. Now we can combine like terms in the parentheses. So 1 plus 1 is equal to 2. And we can factor out a 2 from the parentheses. And we can cancel out the 2's. So the expression for the area in terms of theta is so this is the expression for area in terms of theta. Now we can write the domain for this function. Now in this case, theta has to be greater than 0, because if theta is 0, then the sides of the trapezoid, the non-parallel sides, will be horizontal, and if that's the case, then the channel won't be able to hold any water. So theta has to be greater than 0. And now theta cannot be greater than pi over 2 or 90 degrees, because if theta is greater than pi over 2, then the two sides, the non-parallel sides, will become inwards, and that will reduce the area of the channel. So that means the maximum possible value for theta is pi over 2. So this is the domain of this area function. Now we have to find the angle value that will maximize area. So for that we have to find the derivative of this area function and then set the derivative equal to 0 to find the theta values at which the derivative is 0 or the tangent is horizontal, because the tangent is horizontal at peak points in the graph of this area function. So let's start by finding the derivative of this area function. Now this area function is made up of two functions. One is 1 plus cos theta and then times the other function sine theta. And since these functions are being multiplied, we can use the product rule to find the derivative of this function. So as per the product rule, we start with the derivative of the first function 1 plus cos theta, and its derivative is 0. So the derivative of 1 is 0 and the derivative of cos theta is negative sine theta times the second function plus the first function times the derivative of the second function, and the derivative of sine theta is cos theta. Now we can set this derivative equal to 0 and simplify this expression. So in the first parentheses, 0 plus negative sine theta is equal to just negative sine theta, and negative sine theta times sine theta is negative sine square theta. And in the second part, we can distribute cos theta in the parentheses. Now this equation has both sine and cos, so we need just one trig ratio in this equation, and for that we can use the Pythagorean identity for sine square and cos square theta. So as per the Pythagorean identity, sine square theta is equal to 1 minus cos square theta. Now we can distribute the negative sign in the parentheses. And now we can combine like terms. So cos square theta plus cos square theta equals 2 cos square theta. So we can arrange the terms in the descending order, or the exponents of cos theta from greatest to least. So this is a quadratic equation in terms of cos theta. So we can do factoring to factor this quadratic equation. So if we use the crisscross method, so the factors of 2 are 2 and 1, and the factors of negative 1 can be negative 1 and 1, and if we cross multiply, so we should get a sum of 1, the coefficient of cos theta. So this way 2 times 1 is 2, and 1 times negative 1 is negative 1, and 2 plus negative 1 is positive 1. So we can pair up the 2 with negative 1 and 1 with 1, and we put cos theta with 2 and 1 on the left side. So the factored form is now we can solve this equation by analyzing the two cases. So the first case is and we can move the negative 1 to the right side, and that will make it positive 1. And now we can divide both sides by 2. So we get cos theta equals 1 over 2. And in the domain we just found, so theta should be equal to pi over 3. So this is the first critical number for this area function. Now we can analyze the second case, and the second case is cos theta plus 1. Now we can move the 1 to the right side, and that will make it negative. Now there is no theta value in the domain we found, which will make cos of that angle equal to -1. So this case has no solution. So that means we have to calculate the area of this trapezoid for the theta value 0, pi over 3 and pi over 2, and see which of these theta values give us the maximum area for this trapezoid. So we can start with the lower limit for the domain. So we'll sub in these angle values in the area equation. So this is the equation we'll use. So we'll start with theta equals 0. So A at 0 equals, so we know cos 0 is equal to 1 and sine of 0 is equal to 0. So the value will become 0 because 1 plus 1 is 2 and 2 times 0 is 0. Now we can do the calculation for theta equals pi over 3. Cos pi over 3 is equal to 1 over 2 and sine pi over 3 is equal to square root 3 over 2. Now 1 plus 1 over 2 is equal to 3 over 2. Now we can multiply these fractions. So 3 times square root 3 is 3 square root 3 over 4. And in decimal form, this expression is equal to almost 1.3. And the unit will be meter square because that's the given unit of length. So at theta equals pi over 3, the area of the trapezoid is almost 1.3 meters square. Now we can do the calculation for pi over 2. Now cos of pi over 2 is equal to 0 and sine pi over 2 is equal to 1. So 1 plus 0 is 1 and 1 times 1 is 1. The unit is meter square. So that means the angle that maximizes the area is theta equals pi over 3. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.